All right, guys, welcome to this page of the notes. Hopefully what you've done at this point, you're very comfortable simplifying rational expressions and then finding the restricted domain values. So hopefully you're coming back and just checking your answers, getting lots of practice, or at least brushing up on those factoring skills that we try to develop here in Algebra 2. And here's another one. So we'll go ahead and start by trying to factor the numerator. I only have two terms. We're going to take a look at it. Pretty quickly, I recognize I have a GCF. I can pull a 3y out of everybody. So let's do that. I pull out a 3y, and that's going to leave me with a y plus 7 in the denominator. Well, once again, I think this is the third time we've seen this. I have 4 terms in my polynomial in the denominator. Group and factor, right? We'll group the first 2, group the last 2, and just see what happens. Well, in my first grouping, y cubed plus 7y squared, I can pull out a y squared. That's going to leave me with a y plus 7. In my second grouping, I can pull out, I believe, a minus 9. And that will leave me with a y plus 7. Fantastic. Let me rewrite it again for us now. Completing, right, finishing off our group and factor method. These two factors have to be the same, and they are. So now I finish it by taking my 2 GCFs. They become a factor. And then those guys that had to be the same become my other factor. So I have a 3y times y plus 7 all over y squared minus 9 and a y plus 7. Now, at this point, you're like, ooh, fourth time we've seen it, these should be jumping off the page at you. Y squared minus 9 is a difference of squares. However, I've already found the GCF that cancels. And even if you did decide to go ahead and factor the y squared minus 9 into a y minus 3 and a y plus 3, it won't cancel with anything in the top. So in this case, yes, we found a difference of squares, but I actually don't need to factor it because it didn't turn out to be my GCF anyway. It's just what's left over when I simplify. So we go ahead and do our restrictions for this one. Here's what I get. Y squared minus 9 is equal to 0. Add the 9 to the other side. Take the square root of both sides. Don't forget to do plus or minus. And we get plus or minus 3. What this means is that this is my simplified expression, and I can pick any value of y that I want to except y equals plus or minus 3. Where y cannot equal plus or minus 3. That is going to be your simplified form and restricting the domain. All right, I got a couple more for you here because for most of you, right, Algebra 2 is going to be the most direct application of it. For many of you is going to be when you take those pesky little standardized tests, either the SAT or the ACT. And yes, this will show up on those standardized tests. In fact, here's how they're going to ask you about this particular topic in Algebra 2. Both of these questions are former questions on SATs given in years past. And so let's work our way through these now, knowing what we know about simplifying rational expressions. This happens to be an SAT question. For what values of x, they give you a rational expression. They want to know, when is it undefined? Well, now we know how to do that. The x squared plus x minus 12, hopefully with any luck, that'll factor into 2 binomials, as well as the bottom. Let's see what happens. Well, in order to get the x squared, I need an x and an x. And I need a minus 12 and a plus 1. Well, I think the best way to get that is going to be a plus 4 and a minus 3. Right? 4, positive 4 times a negative 3 is a minus 12, but plus 4 minus 3 is a positive 1, so that works out. Then I need a plus 12 and a 7. Well, again, it's going to be 4 and 3, but now they're both going to be positive, x plus 4 and x plus 3. Well, those x plus 4s drop out, and so now what I can do is I recognize that my restrictions, x plus 3 equal to 0, right? I'm working on my restrictions. What gives me undefined in the denominator? In this case, it turns out to be x equals a minus 3. So, actually, I apologize. I messed this one up. Slight typo here in the notes. I apologize about that. There actually should be a letter choice E, which is then a minus 3, and that will be the 1. Now, that's after simplifying, right? Before you simplify, you just take this guy, set it equal to 0. You'd wind up with minus 4 and a positive 3, in which case D would be the answer, but you got to simplify it first and then figure out for what values of x is it undefined. So again, be really careful on these questions. If minus 3 wasn't an answer choice, that just means they're not looking for you to simplify first. They just want you to take the expression as it's written, take that denominator, factor it, and figure out when it'll be 0, in which case it'd be a minus 4. Minus 4 and a minus 3, so that would be A. If they ask you to simplify it, you simplify it first, then get your restricted domain value. All right, same thing for this guy. Here we go. X squared plus 9. There's nothing I can do to that. Be careful. This is not a difference of squares because that's addition, not subtraction. This guy, though, hopefully it factors. I don't know. Let's find out. Well, the easy bit, I need two things that multiply to an x squared, which of course would be an x and an x. Negative 34 and 15, I need two numbers that multiply to a minus 34, but sum to a positive 15, and actually it turns out it would be a positive 17 and a minus 2. Well, again, nothing cancels. Yes, I've factored, but there's no GCF common in the numerator and the denominator. So for this one, my restrictions are going to be x plus 17, x minus 2. Set them both equal to 0. I get 2 and minus 17. Find that answer, minus 17, positive 2. Right there, we've got B. So I cannot let x cannot be a minus 17 or a positive 2. That would give me division by 0 and therefore be undefined. All right, guys, that takes care of simplifying these rational expressions. We will get more practice on the next page of the notes, but there we're going to look a little bit more at that idea of sometimes needing to factor out a GCF of minus 1 so that you get factors that cancel top and bottom. So head on over to the next page of the notes. I'll meet you guys there.